Hello, welcome to the fourth episode of my submarine project. I know it's been a while, life kind of happened, got in the way. But since the last episodes a couple of months ago, I have basically reworked the entire design. I discuss a lot of the reasons for this in the episode 3, I believe. So one of the reasons is that I want to have 2 ballast tanks, because with one syringe you move the center of mass. Might not be a problem, but you never know. And also it would be nice with buoyancy control over pitch as well. It's a nice feature, just because it's like trying to regulate that with static ballast can also be, I believe, could be difficult to keep it balanced, especially while you're not moving, because since this might be like a little slow moving kind of exploration to start with, at least I want to be able to have control even when I'm like standing still. So that's one of the main reasons for this. Actually, yeah, that's basically the only reason. So, I have for almost a week now been, the 3D printer behind me, have been running rampant basically all the time, the whole week. Not only for the parts which I'll present soon, but you know how it is. Like usually I make some kind of part, and like this for example, little thing. It's like just a sleeve over one of the rods. It's like, you know, the hole is too small or whatever, and you have to redo it. And these big bulkheads, if you remember from the other designs, I kind of kept that before, you know, the same kind of basic feature where you have this bulkheads and you have the big rods going through alongside the shaft. I think that was a pretty good design. Also, you know, I'm kind of basing the entire big project on that, to be able to slide it into the pipe I have. So let me present to you the parts that I have. Down here we can see the parts which I printed out. Let's see if I can secure this. Does that focus? Yeah, good. So we have the big rods. All of these is essentially just spacers. If you remember in the last design, I don't know if I showed you, in episode 2 and 3, you know, I had nuts everywhere, and it takes forever to put the nuts in the correct spacing and stuff like that. It's quite finicky. So instead, what I would like to do is just press everything down from the outside and have everything slick, you know, put together. So wherever there is a gap between bulkheads, I have these sleeves in between. So the basic design, the principle, let's start with this one, because this shows the cut through basically. These 2 big holes is where the syringes go, and here are 2 lead screws, the ones you see here. So I've made some space for bearings in there. So it's a symmetrical design with 2 opposing syringes. The first one is this one here. You can see here goes the syringe, is the idea at least, and we attach the motor from behind. So you can see it's like offset to the side, so you have the motor coming from one side. Basically, if you have it goes like this. Then you have one of these pieces on one side and the other on the other side. So you can see they're opposed. So the one syringe attaches on the upside and the motor on, I guess from my left side, and this motor on the right side here. So it's like they're symmetrical to each other. And then shortly after, we have this one. This is basically only to have to hold the bearings, because we need to connect the lead screw with the motor. I have these NEMA 17 stepper motors. I think it was like 0.43 Newton meters. So 2 of them. So we'll see how well that performs. So yeah, we have these, and they will bridge the gap between the motor. We have these little springy things. I don't know if you can see that. Let's see if I can get focus there. I guess not. But yeah, they're basically like a really thick spring, almost. So it allows for some play. So yeah, this sits behind these, between these, and the syringe goes through here, like this, and it meets up on the other side with this part here. Oh yeah, another modification I have to make. I don't know if you can see this, but it's a very, very low clearing here. It's like a millimeter or 2. And this was very tall. I don't know if you remember from that video, it's like came up a little bit. I've cut this down. You can see more here. So it's like completely flat, like flush with the body now. Like that. So this comes together like this, and here you can really tell so like this, and then you have another piece like on the other side, and it goes upside down. So the reason I have this out here is so the piston of the other cylinder it needs to travel inside here. So, and the margins on these things are incredibly low. I was actually quite lucky that it will fit in this pipe at all, because I don't know if you can see this, but the corner there is super close to the edge, and this thing here is just a millimeter thick, and these things, yeah, it will come out like this. This will have to pass underneath, like it's the opposite piston for the other cylinder. And these things basically need to be able to pass underneath there and have fit another cylinder on the other side. So that took some time and tweaking, and like I had to print out these kind of parts like 3 or 4 times before I got it right. Extending the yeah. So yeah, I already built this together because it was kind of finicky, so I wanted to be able to see that it works before I made this video. All right, let's do some building. I need the loop. I'll pause here for a second. Ah yes, the trusty old multi-grease. Alright. All right. That's finished. And now, let's take a look here. As you can see, it's quite large. So these rods here is as long as the submarine will be. actually even take away like maybe I think 4 centimeters or something like that. That won't fit inside of the pipe. I'll either most likely what I'll do is I drill holes through the lid and attach it to this, so I can make strong connections between like motors and stuff coming out of it and like mount it to the actual lid, for example. So we're talking like maybe here. So there's not much space left. This is a big design, but there's a few caveats. So we have this section here, of course. We have a lot of space here that's not used. Maybe I can redesign this somehow. I take away some of the. If I really need space, I can probably cut out, well not cut, but print a new part. Basically, take away this part here. So yeah. Same on the other side, of course. All right, let's talk about. Oh yeah, and there's quite significant amount of space on the sides here. If you can see, the whole thing basically fits within. Let's see. Everything fits quite vertically like that. So even though you can't really tell because of the rods, but like everything from side out is free game. So I can probably put batteries and stuff along here, or electronics. Maybe we'll see. I also got, some preemptively bought this. We'll see if I regret it. Basically, it's a little motor with a out. We'll see, maybe I'll probably replace the propeller. We'll see if I feel like it's way too small. I hope this motor is going to be strong enough. I mean, it says it's 60 amperes at 12 volts. I mean, that's a lot of power. I mean, what is that? That's like 360 watts. Am I doing this correctly? No, more. 720 watts. 700. Wait, 12 times 6. Yeah, it's like 720 watts. That's insane. Yeah, and a speed controller. This is actually 50 amperes, so I'm not sure what I thought when I bought this. We'll see how it turns out. We'll see. They're also water cooled. I'm not sure if that'll help if I need that. But so yeah. Oh, don't worry, I'm not dying. All right. Let's see if we can do this. Let's see if the mechanics work here. So this motor on the left side here drives the rod on here, and it is attached to this little thing here, which holds this. So if we turn it, it should move it. It turns pretty well, actually. So yeah, one design consideration when I was kind of building this, I was mostly focusing on the 2D, the cut through like this. I wasn't focusing too much on the length of it. So maybe that'll change a little bit. We'll see if need be, but it actually turned out quite well. Because it like goes almost. Oh, I put this syringe upside down. I guess it doesn't matter. You can't really see, but let's try the other one. Oh, that doesn't turn very well. Oh, maybe this needs to lube up a little bit. Like all the way there, it's at 95 milliliters. So it's almost like what I was hoping for. So it's a total of 190 milliliters. And I think I calculated the tube should be the tube should be like 6.2 liters, I think. That's what I'm thinking. So 190 milliliters should be, I think that should be ample, you know, to have a good control authority over it, to sink and rise quickly. This video was mostly covering the mechanicals of it. I think next video I'll go over the electrical system and how we do that. I haven't really figured it out yet. You know, we work as we go. So yeah, we'll see. If any of you have any ideas of where we can put the rest of the stuff, let me know in the comments below. So what we need is, we need to fit this motor somehow. This can fit basically inside there. I don't know how much space that takes like this. We don't have very much left over. And of course the speed controller, and the biggest problem is batteries. Like, and of course all the electronics, but those are small, we can scram them away somewhere probably. But I bought this because this is quite stable. It's what was it, lithium ferrum or something like that? Ferrum? I think it's lithium ferrum, so lithium iron, I think at least. Because it's much more stable and safe than lithium ion, and it's not as, you know, it's not as energy dense as well, which makes it quite suitable when you don't need, you know, when you're not very concerned about weight and stuff, which we're not here. Honestly, I think it's actually, it's too light at this point. I think we're not pushing like 2.5 kilograms, and we need to go up in like 6 kilograms or something like that to make it sink. So, or, you know, neutrally buoyant. So I wanted something heavy and big. The problem is the form factor of this is like I can't really fit it anywhere. You know, like it takes up the entire backside here, and then we don't have any space for anything else. So I think what I probably need to do is have multiple batteries, like 2 or 4. The thing is, it's very important to have it symmetric, you know, along this axis, so it doesn't tilt over. I'm not sure exactly how important that is, because probably, you know, with this design I don't really have any space for any, you know, static ballast in the bottom very much. So I'll probably hang something underneath the submarine, or something like a pipe or something with heavy, like a smaller pipe underneath. So maybe it doesn't matter that much, but probably what I will do is probably attach 4 small batteries on the side here. We'll see, and maybe some electronics on the front, you know, hopefully if we can fit a camera or something. But yeah, if you have any ideas of like layout and stuff, let me know. That would be appreciated if someone comes up with a great idea. Alright, that was it for all today. I'll see you in the next episode, where we probably cover some electronics and maybe some programming, or either or of those, we'll see. Yeah, probably, at least we'll get motors moving. That I can promise you for the next episode at least, unless something inexplainable happens. Alright, see you in the next video. Like and subscribe. Thank you. Have a good one.